Hi everyone, in this video we look at a couple of examples involving negative exponents. So here we're told to rewrite with positive exponents, and the question actually should say write with positive exponents and simplify. So let's go ahead and we'll rewrite a with only positive exponents. Here I have x over y to the power of negative 2. Well, remember in the last video that we said that x to the power of negative n, well, that's equal to, I can take the reciprocal and flip the sign on the exponent, and I can write this as 1 over x to the power of n. Similarly, if I have 1 over x to the power of negative n, I can make the exponent positive by taking the reciprocal. So this is equal to x to the power of n. So here I've got x to the power, x divided by y to the power of negative 2. And if I want to change this into a factor with positive exponents, I have to just take the reciprocal of y to the power of negative 2, and I can rewrite this as x times y squared. Now, if you're wondering why is this equivalent to x times y squared, well, y to the power of negative 2 we said was 1 over, should be using this identity, 1 over y squared. So I can write this as x divided by 1 over y squared. Now, division by a fraction, remember that this fraction bar actually means division. Division by a fraction is the same thing as multiplication by the reciprocal. So this is equal to x times y squared over 1, which is just equal to xy squared. So this simplifies to x times y squared. In the next example, I can simplify first using the exponent laws. Here I have x to the power of negative 2 divided by x to the power of negative 5. And when you're dividing powers of the same base, you subtract their exponents. So I've got x to the power of negative 2 minus 5. And then I have y to the power of 3 minus 4. Negative 2 minus 5 is just positive 3. So I have x to the power of 3. And y to the power of 3 minus 4 is y to the power of negative 1. Now I can change y to the power of negative 1 to a positive exponent by taking the reciprocal of y to the power of negative 1. So I've got x to the power of 3 over y, because 1 over y is the reciprocal of y to the power of negative 1. Or 1 over y is the reciprocal of y, sorry. Okay, so next we have 4 times a to the power of negative 5 times b to the power of negative 4 divided by 16a to the power of negative 7 times b to the power of negative 11. The first thing that I would probably do when simplifying here is just to simplify any coefficients, divide out any factors if I can, and also then use the exponent laws to simplify. So 4 divided by 16, well, I can rewrite that as 1/4. And I can use the exponent laws to simplify. I'm dividing powers of the same base, so I subtract their exponents. I've got a to the power of negative 5 divided by a to the power of negative 7. This would be a to the power of negative 5 minus 7, which is a squared. Then I have b to the power of negative 4 minus 11, which is b to the power of 7, because when I subtract negative 11, that's the same thing as adding 11 to negative 4. Now I can rewrite this. Well, this is actually simplified enough, and it's rewritten using positive exponents. But another way to write this is that this is equal to a squared b to the power of 7 over 4. Either form is correct. In example D, I have negative 2 x to the power of negative 5 times y to the power of 3 to the power of negative 2. So there's a couple different ways to do this, but the first thing that I think we should do is first take the reciprocal here to change this exponent into a positive exponent. So I can rewrite this as 1 over minus 2 x to the power of negative 5 times y to the power of 3 to the power of positive 2. All that I've done is I've taken the reciprocal of this to make this a positive exponent. Now I can go ahead and I can square everything inside the bracket. So if I square this factor, negative 2, I get positive 4. If I square x to the power of negative 5, I have to multiply their exponents because I'm raising a power to a power, so I multiply the exponents, and that gives me x to the power of negative 10. Now I've got y to the power of 3 to the power of 2, which is just y to the power of 6. And lastly, I have to rewrite this using only positive exponents, so I can take the reciprocal of x to the power of negative 10 and rewrite this as x to the power of 10 divided by 4 y to the power of 6. Okay, so next we're asked to evaluate x to the power of, 2 to the power of negative 600 divided by 8 to the power of minus 199. Now sometimes you'll see teachers put questions like this on assessments because you cannot use your calculator to evaluate these types of expressions because it'll give you an overflow error. Your calculator can only take so many digits. So sometimes teachers will put questions like this on evaluations and assessments so that you have to use the exponent laws and that you cannot use your calculator. So the first thing that I would do in this example is I would probably write this using positive exponents. So here I've got 2 to the power of negative 600. I can take the reciprocal of 2 to the power of negative 600 and rewrite this as a fraction over 2 to the power of 600. I can take the reciprocal of 8 to the power of negative 199, which is just 8 to the power of 199. Now notice that to simplify this using the exponent laws, I would have to divide, but this power does not have the same base as this power. The base here is 8 and the base in the denominator is 2. But notice something. 8 is a power of 2. So I can rewrite 8 as 2 to the power of 3 to the power of 199 divided by 2 to the power of 600. Now, 2 to the power of 3 to the power of 199, well, I know how to simplify that. That's just equal to 2 to the power of 597. I'm raising a power to a power, so I just multiply the exponents. In the denominator, I've got 2 to the power of 600. Now that the bases are the same, I can use the exponent laws for division. When I'm dividing powers of the same base, I subtract their exponents to simplify. So I can write this as 2 to the power of 597 minus 600, which is 2 to the power of negative 3. And 2 to the power of negative 3 is just 1 over 2 to the power of 3, which is equal to 1 over 8. So you can see that something that our calculator can't evaluate, we can evaluate if we're clever and we use the exponent laws.